let's look at some guidelines for graphing rational functions. So we're given some type of polynomial where we have a function, a polynomial in the numerator, a polynomial in the denominator. So the first thing you do is simplify if possible. So you're going to factor. Then if anything cancels out, make sure that you remember that they are still a restriction in your domain, and then those will be wholes. Then you find and plot the y-intercept by evaluating f of 0. So remember, make x equal 0, and then you'll find your y-intercept. To find the x-intercept, all you do is find the zeros of the numerator, if there are any. So that's the shortest way to do that. Then you find the zeros of the denominator. Remember, the zeros of the denominator are our vertical asymptotes. We cannot have those values. It's a restriction. Then you find and sketch the horizontal asymptote, if there are any, by evaluating the degrees of the numerator and denominator. Then you plot 1 point between and 1 point beyond each x-intercept, and then you use smooth curves to complete the graph. So let's try this example here. Sketch the graph of g of x equals 3 over x minus 2. So one thing that we know for sure is we look at the denominator and we know that we have a vertical asymptote at x equals positive 2. We know that is a restriction, so we draw that right away. Then we see that we have a degree of 0 at the top, so it's just 3 over x, and so that reminds me of 1 over x, which reminds me that our horizontal asymptote is y equals 0. Then y-intercept is when x is 0, so 0, and so that gives us negative 3 halves. So 0, negative 1 1/2 is right here is our y-intercept. Then the x-intercept, so what that is, it's our zeros of our numerator, and so we have a 3 in the numerator. So what that means is we don't have any zeros, or we don't have any x-intercepts. Okay, that makes it nice and fast to find. So then we need to plot some additional points. So it says to pick a point beyond the vertical asymptote. So let's go ahead and look at this, and we see that we can pick 3. If we plug in 3 over 3 minus 2 is 3 over 3 minus 2 is 3 over 1, so that's 3 here. And then a nice one to pick out is 5, because 3 over 5 minus 2 is also 3 over 3, and that's, well, not also, but 3 over 3, which is 1. Okay, so that's nice over here. Now, if you remember graphing these last year, you can graph it using transformation. So you can only use it in this form when it has something like this. And the other ones, you just kind of have to plug in values. So I know it's reflected on the other side. So I know it's going to be from this point here, it's going to be 1 left and 1, 2, 3 down over here. And then we can go 1, 2, 3, and then 1 over here. Again, you can just plug in points. So if you plugged in positive 1, you would get a negative 3. Okay, so that's one way to do it. Then you think about your domain, or our domain. Our domain is all real numbers x, except x when x equals positive 2. So try out this example here. Sketch the graph of f of x equals 1 over x plus 3. So pause video, and when you come back, I'll have the answer for you. So after we tried this out, we know that our y-intercept is at 0, 1, 3, so I made x equal 0. X-intercept, so I have no zeros in my numerator, so none. My vertical asymptote is at x equals negative 3, that is where it is undefined. The horizontal asymptote, because the degree is larger in the denominator than the numerator, that is y equals 0. Then my domain is all real numbers, x, except x cannot be negative 3. So let's try this next example. 2x minus 1 over x. And let's see, we know right away that our vertical asymptote is the denominator, x equals 0. Our horizontal asymptote, now the degree is the same in the numerator and the denominator, so it's just the leading coefficients that help us with our horizontal asymptote. That is at y equals 2. Our y-intercept, so we're making x equal 0. Well, we can't. So there are no y-intercepts, right? If we make this 0, that doesn't exist. So there's none. X-intercept is the zeros of the numerator. So the 0 of the numerator is 1/2. And let's see, now we can plot some points. So in this case, I'm going to have to pick some values. So x-intercept is here. So let's plug in 1 to the right of the x-intercept is 1. So 2 times 1 minus 1 over 1. It's 2 minus 1 over 1, which is just a positive 1. And then I kind of know what the graph is going to do with this point. You could plug in 2. So 2 times 2 minus 1 over 2. That's 4 minus 1 over 2, or 3/2. Okay, so you're kind of seeing the picture there. Then let's pick numbers to the left of the vertical asymptote. Let's choose -1. So 2 times -1 minus 1 over -1. That's -2 minus 1 over -1. So that is -3 over -1, or a positive 3. Then you're kind of seeing the pattern on this, and so we see that this is our graph. So our domain is all real numbers x except when x equals 0, right? We can't have 0. So try this example here. Pause the video and try it out. So if you try this example here, you would have gotten the y-intercept of 0, 3, right? You make this 0, that's just 3. X-intercept, so just the zeros of the numerator, is -3/2. And then the vertical asymptote is at -1. Horizontal asymptote is y equals 2, because the degrees are the same, so it's just the coefficient. And then you plot a couple points, and that is it for this one. Thanks for watching, and I hope this helps.